Now we have Module 15, which is the start of our trigonometry modules. We're going to talk about angles and radian measures to get us started. First of all, before you go into this module, make sure you've taken a look at the guided instruction activity number 2, which is called Measuring Triangles. This is an interactive activity that introduces you to measuring triangles, that's where trigonometry comes from, and its connection with the unit circle, which we're going to talk about in this video as well. So it's very helpful if you at least view the video. If you aren't able to print out the accompanying worksheet so that you can actually cut the triangles out and manipulate it, which is the idea behind learning deeply by doing, then at least take a look at it and you'll get in touch with some of the concepts we're going to take a look at this. So I'm not going to try to replicate everything from that video, but build upon it going forward. So first of all, some of the items may overlap, but we will just see. So here's a circle. That's what we're going to start with for this one because we're talking about angles. One way of measuring angles is kind of the central part of of a circle, or we look at the interior side. And one way of doing this, invented by the Babylonians, probably others as well, is that if you go all the way around, they call that 360 degrees. So we have degree measure. And we measure how far open this is, and we just take a circle and segment it into 360 equal little rays coming out like that. So that's one way of measuring. The other way of measuring is to actually walk along the circle and see how long you've gone. So we'll talk a little bit about that one. That's called radian measure, which we will be using both of them because in trigonometry, that's what we need to do. So radian measure, is a different concept. It's really applies directly to the circle, but we could also, we're going to see there's a connection between these two ways of measuring. So if I kind of imagine this angle being fit in here, what a radian is a walk along the outside, and what you'll see is that it takes into account the radius itself, and so we generally will use a Greek letter theta to represent the angle in radians, and it's going to be the distance we walk, which is s, divided by the radius. Now we are in trigonometry, we use what's called a unit circle where the radius equals 1. And so you'll see that actually when we're doing that, the theta, the number of radians, is actually just the distance along here because we let r equal 1, and so it makes it a lot easier. But if you do with a circle that doesn't have a radius of 1, then we have to use this little conversion to figure out how many radians are there by walking along the circle. Okay, so we're going to do those two. Now, along with that, we're going to think of, we have a full circle, so it would be, again, talking about degrees, we start at 0 degrees. As we go all the way around, we made it to 360 degrees, and so they divide it up. Well, we could put little segments all 360 of those, but it might not look very good. So what we want to talk about is sort of our main angles that we're going to deal with in trigonometry. And so we have kind of 4 divisions of the circle right now. We'll talk about this as a 90 degree. This would be 180 degree, and this is 270. And we're going to go through this again and but mainly how we would divide it. Well, the other way, one sort of natural way to divide this is now we've got these quarters, to divide each of them in half. And again, with construction and stuff, a lot of times we want 90 degree angles, but sometimes we want a 45 degree angle. And so we go around the circle, and let's see if I can do this. Divide each of these circles in half, or quarters, I guess, quarters of a circle, right? And what we see is this is 45, add 45, you get to 90, add 45, you get around. So that's one way of dividing it. Another way that goes with this, let's see if I change colors here, is to divide the quarter, this little segment here, this quarter, this 90-degree quarter, divide it into thirds. So there would be 30 degrees here, another 30 degree added on gets us to here, so 30, 60, 90. And we're going to see that as we go through, we'll take both of these into consideration. And but if you look at it, there's really two different ways of dividing up the circle. Cutting it in half into the 45 degrees, and then cutting it into thirds, 30 and 60. And while we list them all together, as you go and count them and put the angles in, a lot of times it's easier if you look at it as really being two different processes, a red process and a blue process here. So we're going to work with that. Okay. So two ways to measure the circle, as we mentioned, the radian, or the degrees and the radians. So we're going to start with the degree measure and just kind of go through. So where we start, let's see, we'll do it with the circles as these ellipses. So that could be 0 degrees. This is your 30 degrees. And I'm going to skip over this one. So I'm going to count by 30s. 30, 60, 90, 30 more is 120. And again, these are all degrees, so you should have little degree marks, right? Add 30 more, that's going to give us to 150. Add 30 more, we get to 180. Add 30 more, we get to 210. 2 more, or 30 more, and we get to 240. 30 more, and we get to 270. 30 more, and we're at 300. 30 more, and we're at 330. And 30 more, we're back to 0 or 360, right? So this angle here is both. Okay, and then what I do is go back and fill in. Okay, the other way to count is to go by cutting it in half. So I go to 0, I go to 45. Add 45, I've got to 90, so we see that connection. 90 plus 45, that's going to get us to 135 degrees. I should be doing degrees on all of these. Add 45 to 135, you get to 180, so another common angle between the two systems. 180 plus 45 is going to get us to 225. But see how it's actually easier to think your way through these because now we're adding 45s all the way around. 225 plus 45, that got us to 270, a common angle. 270 plus 45 is going to get us to 315. Notice that's between there. And then 315 plus 45 gets us to 360. So that's kind of the way to think of the divisions of the circles in degrees. Now, when we get to radians, let's see if I can fit it on here. I wasn't sure if I could. Actually, I'm going to go to the next slide. I may come back to this, but you could use this. And there's a point where we'll look at these, the coordinates of these points on the unit circle. I kind of allude to it in the measuring triangles activity. You'll see that these really come from that. And what you start to see is, hopefully you start to see, is from that activity, this circle also contains, draw it this way, a triangle. You know, all of these right triangles. Here's a 45-degree angle, and I go this way. And the right angle's always on to the x-axis if you do that. And you know, so you've done that activity, hopefully. But you see that each of these can be thought of as a triangle. And so there's really Three main triangles that we have that we use. If we know those values, we're going to use it. Not that there aren't other angles. There is a 15-degree angle, but what we do is we use these three because they're kind of our main angles for construction and building things, as well as once we get these as exact angles, we learn trigonometry, and then we can apply it to the other angles, which are their exact form is oftentimes difficult to get. Okay, so I'm going to show you with radian measurement we do the same thing, but I'm going to do this in two separate ones because it could get a little messy. So here's 45, here's the 90. I'm not going to, I guess I could draw it in, but it's already there. And then we cut this one in half. And again, those are 45 degrees. But let's talk about it, what it would be in terms of radians. So in radians, and again, if you watch the video, we start at 0. As we go around down to here, this ends up being 1 pi, or just pi, right? But 1 pi. It's 3.14, assuming that this radius is 1, so it's over there. This 90 degree would be halfway between 0 and pi, so it's going to be pi over 2. And this 45 degree angle, it's halfway between 0 and pi over 2. So if you get, half of pi, half of a half is a fourth, pi over 4. So I like to think of these as we go around, we're just counting by fourths. So this is 1/4. This one you could think of, if we count by fourths, is 2 pi over 4, or 2/4, right? It reduces down to 1/2, but watch how it helps when we count. So this is 2 pi over 4, this is going to be 3 pi over 4. That doesn't reduce. 3 pi over 4, we keep counting, this is going to be 4 pi over 4, which reduces down to 1 pi. But now that I've got 4 pi over 4, I can keep counting. This is going to be 5 pi over 4. That doesn't reduce. Down here we get 6 pi over 4, but that will reduce. 2 goes into both of these, so that gives us 3 pi over 2. But if when you go directly to this, sometimes it's hard to make those connections. But look at it as just counting by fourths, right? 6 pi over 4, what's the next one? 7, we're just counting. 7 pi over 4, and we got all the way around, that's 2 pi, right? Or it's 8 pi over 4, which reduces down to 2 pi. And I think that'll help you when we need to do conversions and such with fractions. 2 pi is multiples, so 8 pi over 4 to get your common denominator. Okay, so that's one way of counting over here. Again, it got a little messy, so I think it was good to do that. If we do it in thirds, so we have, let's start here, we're going to have this one, that one, there, and remember this is always going to be pi, 1 pi, so 0 to 1 pi. And notice we've got 1, 2, 3, 4, 5, 6 segments, so we've divided pi into 6 equal little slices, so this has to be pi over 6. And again, what we're going to do, we'll do the bottom half later, but pi over 6 we're going to count, so this would be 2 pi over 6, which is reduced down to pi over 3. And again, we talk about pi over 3 a lot, but it's really 2 pi over 6 as well. So 2 pi over 6, and then we keep counting. This is going to be 3 pi over 6, which does reduce to 3 goes into both of those, pi over 2. So there's that connection. But we just keep counting. So if I have 3 pi over 6, this is going to be 4 pi over 6, which does reduce. 2 goes into both of these. So I could rewrite this as 2 pi over 3. But again, it's just easier on the brain thinking in terms of counting by 6. 4 pi over 6, this is going to be 5 pi over 6, and that would make this 6 pi over 6, or just pi. Okay, and then again, we divide each of these into thirds. exact segments, but we'll assume that they're all the same, and we just keep our counting. 6 pi over 6, so this has to be 7 pi over 6, doesn't reduce. 8 pi over 6, which does reduce. 2 goes into both of those, so we usually will write this as 4 pi over 3. This one, 8 pi over 6, so this has to be 9 pi over 6. Again, 3 goes into both of those, so that's going to give us 3 pi over 2. So that connection. But with the 9 pi over 6, I can say, okay, the next one's got to be 10 pi over 6. 2 goes into both of these, that's going to give us 5 pi over 3. Okay, so that connection. 10 pi over 6, one more 6 would be 11 pi over 6. That doesn't reduce. One more pi gives us 12 pi over 6. 12 divided by 6, there's our 2 pi. Okay, so that's a way of thinking of the radian measures. And again, a lot of times all we see on the unit circle are, you know, the reduced form, but just remember how you could get to that reduced form. It's a lot easier on the brain to just count in terms of 6 with this. The other one, count in terms of fourths, and then reduce as you go. You'll make those connections better. Okay, and then let me back up here so we could start seeing what we did with this. So we found that this was pi over 6. This was pi over 4, so those are our main angles that we're going to use, right? And this was pi over 3 in its reduced form. But remember, it's also 2 pi over 6. And this one up here is pi over 2. And again, you can go through and fill in those ones we just went through here. And then eventually, there's a video a little bit later on that connects it with the points and how to remember these points on the unit circle. But for Unit 5, we're dealing primarily with degree measure, radian measure, and converting between the two. Okay, so I think we'll leave it at this for now. And then we want to talk about a couple things like what does it mean to be a negative angle? Well, first of all, what really is a positive angle? It just means we're going to measure it from 0, what is this, counterclockwise. So this is a positive angle measurement. Negative angle measurement just simply means we measure it in the other direction. So we go clockwise. Okay, so that's a negative way of measuring. So we always start at 0. So we could do either one of these. So if there's a negative angle, it doesn't, you know, we think of a negative number as maybe be the absence of something, but in this case, it just, we want to think of a negative as really being an opposite. We're measuring it in the opposite direction. Let's see. Well, before I do that one, let's talk about what coterminal angles. I think this is a place I want to talk about. No, I'll talk about it next. That's right. I'm going to use the same drawing to talk about coterminal angles. But converting degree measure to radians. So what would 35 degrees be? Well, what we need is we need some kind of conversion factor. So we need some place, somewhere where we know both the radian measure and the degree measure. And a convenient one to use is that 180 degrees is equal to pi in radians, that these are equal. And so if you've done any unit analysis before, what you'll see is that it gives us a factor of either pi over 180 or 180 degrees over pi. Since they're the same thing, these are both really equal to 1. When we multiply something by 1, we don't change it. Now, numerically it'll change, but what we're going to do is, so if we have 135 degrees, if we want to convert this to radians, what we'll do is we'll multiply. We want to divide out the degrees, so we use the one with the pi over 180. If we're converting from radians to degrees, we use the other one. So we'll get some practice with that. So this is pi over 180. So notice the degrees are going to cancel out, and we're left with 135 180 pi. If you remember, we got both of these by counting by 45 degrees. So 45, and here's 45 degrees. 1, 2, 3, 45 goes into 135 3 times. 4 goes into 180, 1, 2, 3, 4 times. So that's 3/4 pi. So 135 degrees is also 3/4 pi. You might have got that. Negative 135 is also negative 3/4 pi. So we can use either way with these. Okay. So now let's talk about coterminal angles. What is a coterminal angle? Well, the word terminal, we want to use the meaning of it's the end point. It's when you get to the end. Okay, so it's where it ends. Co in this term really ends up meaning the same. So they're ending at the same spot. We use this when we go multiple times around a circle. So we'll see. Yeah, so if this is our angle, we could just go there, or we could go there and then go around the circle and come again. And this happens think about like a wind-up toy. You can wind it around more than one time around the circle, right? And there's a spring in there. The more times you wind it, the more power it's going to have. So that's what we use trigonometry for. Is sometimes we're going to wind that spring up multiple times. Okay, but in a sense, where is the location? Where's the end location? What you'll see is there's multiples of 360 degrees. The other place we use it is we've got negative. If we've got a negative angle, remember it's just measured the other way. We might want to know what is that positive measure of that angle. We have the same concept of coterminal angle. So let's see how this works. Come back to this drawing. So first we'll start with the negative angle, and then we'll look at a couple examples with coterminals. So this is, I could think of it as negative 135 as it's listed there. Another way, another angle I could use, another measure that I could use for this is I could measure it from 0 positively. I would have a different number for this, right? And it's going to be positive, but this is both of these angles, the red one and the blue one, are ending at the same place. They are coterminal. How would I measure this one? Well, notice that all the way around the circle is 360. I've gone negative 135. So one way to calculate this is to say, well, 360 is all the way around. If I subtract off this negative angle, 135, what's left will be the positive side, right? And you can kind of see it's going to be a little bit bigger than 180, right? It should be 180 plus 45. It's going to be like 225. And if you do this subtraction, that's how you get, let me subtract this way, it's easier for me. So we get 5 from 10 is 5, 3 from 5 is 2, 1 from 3 is 2. Yeah, we get 225 degrees. So that's a coterminal angle. And oftentimes we want that because we want to say, okay, we want to be here, but we would like to see what that angle would be if I measured it in the positive direction. So these angles are really equal. They are coterminal. They're different in a way because, again, like if you think of a spring, you're winding it in a different direction. So there is a difference, but they end up in the same place. That's the idea of a coterminal angle. They're not really, so maybe I really shouldn't say that they're equal, but they are coterminal. So let me take that out. That's just my way of thinking. They're coterminal. What's equal about them is their endpoint. But again, because they were measured differently, there's also something different about it. Okay. We could also think about this. So let me go ahead and clear this all out. Well, it's going to delete them all. I think I'm okay with that. So another way is to think about, this is 135 degrees, right? But that means it was measured just from 0 to there. Thinking of a spring, let's go with red, just maybe I went around the circle one time and went around the circle again, and then I stopped there. So what did I do? Well, one time around the circle, that's 360 degrees. Then I went around the circle again, so I added 360 degrees. And then I went from 0 to 135. So this will give me a coterminal angle for 135. But this is going around the circle twice. So 5, 6 and 6 is 12, plus 3 is 5, right? It's 12, 3, 5, carry the 1, and that's 6, 7, 8, 855 degrees. So these are coterminal angles. So another name for 135 degrees, I could also call it 855 degrees, again, as far as just focusing on the endpoint. But 855 is in somehow different because it has wrapped around 2 times around the circle and then the 135. 135 is just, whoop, we went there and we stopped. Okay, and what you're going to see is oftentimes the questions will give you like an angle like 855, and the way we get to the terminal angle, they'll want the angle either to be measured between 0 and 360 degrees, right? Because they just want to see, well, what is it? What's that end point, just considering one time around? Or they'll ask for it between 0 and 2 pi. This is not subtraction, it's just, I should write the word 2. So they want 0 to 2 pi, which again is just one time around the circle. So we're going to look at a few examples when it's larger than 360, we just repeatedly subtract 360, right? Because here we were adding on how many times. So we just figure out how many times we could subtract 360. That'll get us to there. If we have a negative angle, then we want to subtract that from 360, maybe multiple times until, again, we get a number that is, as we did last time, ends up being positive, and between 0 and 360, or between 0 and 2 pi. Okay, ideas of coterminal angles. A couple examples here. So we want to find an angle between 0 and 2 pi, so just one time around the circle. That is coterminal to this one, 31 pi over 6. So you could kind of see, yeah, 6 goes into 31, certainly more than twice, because 12 pi over 6 would be 2 pi, right? So it's more than one time around the circle. So one way to kind of think of, well, how far around the circle? Since we're dealing with 6s, remember this is how we counted. If I go around one time, that's going to be 2 pi, or if I'm counting by 6s, that was 12 pi over 6, because it's just going to make the mathematics easier. So 31 pi over 6, that's what we've got. I'm going to subtract off 12 pi over 6 and see where that gets me, right? Because I need a common denominator. 31 minus 12 is going to be 19. Right? Let's see. Going vertically is always 2 from 1, so that's 11. That makes 9, yeah, and that makes 1, so 19. This is still bigger than 12 pi over 6, so let's subtract it again. If you would have said, okay, right, one time around will be 12 pi over 6, 2 times around will be 24 pi over 6, right? You could count that way. 3 times around would be 36 pi over 6. So we see it's between 2 and 3 times around. So if you want, you could jump to just subtracting 24 first, however you want to do it. So this is 1 time, 2 times, and this is 3 times. Okay, but when we subtract it this time, we're going to get 7 pi over 6, which is less than 12 pi over 6. So This is just one time around the circle. This is between 0 and 2 pi. That's our answer. So 7 pi over 6 is coterminal to 31 pi over 6, and it's between 0 and 2 pi. Now 19 pi over 6, that's also coterminal to 31 pi over 6. So these are all, they're coterminal, but the one they wanted for their answer is the one between 0 and 2 pi, which is just one time around the circle. And where is that? Well, remember 8 pi, let's see, 7 pi over 6, 8 pi over 6 pi over 6. Let's back up one. 6 pi over 6 would be just pi when we counted. So 7 pi over 6 ends up being like here. 8 pi over 6 would be this next one, and then 9 pi over 6 is down here. Okay, so get used to working with those angles. So what do we have next? Well, we have the end of our module. Thank you for paying attention. What you should do now is this should provide enough information to get you into Module 15 in ALEKS and working through those learning activities. Remember, we do have the online tutoring available. We have instructor office hours, as well as working with peers in the various discussion forums we have available in Canvas. So thank you for listening, and we'll move on to the next one.